Oh, there it is.
Woohoo! We're lively. Welcome everyone to week 7 of Nand2Tetris, or week 7 of Mike and Dan, whichever one is more accurate. I'm Mike Reese. I'm studying along with the Nand2Tetris, and so having lots of fun. And my day job is Ruby, so it's kind of fun to get down to the lower levels for a change. Dan, you want to jump in?
Yep, I'm Dan Dorman. Yeah, I'm just studying along with Nand2Tetris as well. Been having a blast in the last couple of projects in Clojure. I don't know if the Clojure is great Clojure, but it's been fun doing more Clojure, so having a good time.
I forgot to tell you, Dan, that I finally actually did bite the bullet, and I'm learning Clojure for the sake of ClojureScript and Ohm. And I have an own project actually in progress. So
that's awesome. How's it going?
I'm in love. What can I say?
It's pretty great.
I dream about Ohm every night. David Nolan is my new man crush. So
he's pretty good.
He's a dreamy guy. So I think we'll start off as normal and kind of just say kind of run over the chapter, kind of what we learned from the chapter. So this week I intentionally only read up through the kind of theoretical parts of the chapter, and I tried really hard to not read anything once it got into the suggestions of how to implement the virtual machine translator. The last couple of weeks, each of our implementations were very, very similar to each other, and I think it's because the book does a very good job, to its credit, of trying to lay out a path so that students who are just following along with this stuff for the first time can get these projects done in a reasonable amount of time. But I thought it'd be fun to not read that and see if our answers still converge towards something similar or if they were very vastly different. So I'm curious to see that. But from the parts of the chapter that I did read, it seemed like the only thing that really stuck out as difficult or tricky was the idea of the this and that pointer. And since we're not really dealing with the object-oriented part of the virtual machine yet, I sort of have an idea of, it's kind of like when you call between objects, it seems like you'd push those 2 pointers onto the stack, like the main stack, and then put new pointers into those 2 pointers for the current object in the one you're talking to or something. But it didn't really gel for me. Did you have, was that a similar thing for you?
Yeah, it's a good point. Actually, it just sort of stuck out to me at the time, but I didn't even think about it. That it wasn't like the difference there. Yeah, that's a good way of putting it. It was interesting because I have a vague idea just from programming what this and that kind of mean, but without having seen it in practice, it's sort of all guesswork right now what that's probably going to be used for. So it is kind of it's an interesting idea.
Yeah, they had kind of that section where they were saying okay, we're jumping forward to really the next chapter here for this section because we're going to talk about how the object system works in our theoretical language, and so it seems like they probably dove more into details. But I was afraid that reading that section would again give away a lot of the ideas of how they thought about implementing the virtual machine. So I didn't read it for the sake of wanting to kind of discover it, or wanting to have that feeling of discovering a solution to how to implement this virtual machine on my own. So I don't know, maybe that'll totally end up biting me next week.
I don't know, so as far as not looking at the implementation, did you look at the memory mapping at all? Because that's kind of critical to how the underlying architecture even works. So
yeah, I read the little table. I basically read up to the point where they have the little table that says okay, we basically use, the first 16 words of address are used for these specific purposes, and then everything down to 256 is used as the temp, and everything from 256 onward is the stack, and then we have these little slices for the other stacks, basically, that you keep, the local stack and the arg stack and stuff like that. So, and those aren't even really stacks. They're almost more just indexed arrays. And it doesn't seem like the bounds of those arrays ever change from what I can tell. But literally, I read up to that memory map. And then the only other thing I really learned about the virtual machine is using the virtual machine emulator that they provide and just loading in the .vm files and running through the steps to see how it mutates the stack. Because I even wasn't sure, like, when there's the less than operator, I wasn't sure what the, like, because you push two things onto the stack and then you say less than, and I was like, okay, well, do you want the thing that's now at the top of the stack to be less than the thing behind it, or do you want it the reverse way? And I wasn't sure, and I had to just kind of like run those things in the virtual machine emulator to kind of figure out and just discover what the virtual machine was trying to do. And then that was what I used to base my implementation off of.
Okay, that's fair. That's fair. Yeah, I really kind of just skimmed the implementation. I still feel like a cheater compared to you, but I really like just kind of skimmed the section because it's like, I'm doing this enclosure. I already kind of know how I want to do it, so it's just kind of like, I'm not going to use any of these method names, so I just really like glossed over that. Mostly what I kept referring to was like that memory map and things. The pointer, but some of it was like so straightforward, like the pointer stuff, the this and the that, were just like essentially aliases for other memory locations. So there wasn't a great deal of difference, so it was a little easier, I think, to do that since other stuff was already done. I don't necessarily know if I necessarily want to like. I think we should like start with me because I think yours will be much more interesting, and I don't want to necessarily just go over the code again because I feel like that was super boring last time. I was like boring myself talking about it, so I'll just try and like talk about it like from a high level, and then like the one thing that I found that was like that really tripped me up for a little while. So I'll lead with just kind of the high level thing, but it's very similar to the same approach I did last week, where I kind of like just get a quick parsing of the just raw lines from the file, and then transform that via different stuff into a series of instructions, and then basically just dump those out. So that's basically like the two stages of it. There's not really much to it more than that. Just parse the lines, and then go ahead and take those parsed lines and transform it into the ASM stuff. It was interesting. I saw your comment on the Google Plus thing about the like multiple pages, or the multiple files, concatenating those into a file. And I actually haven't solved that yet either, because like nothing we've had to do has pushed for that to need to exist. But I'm not too worried about that because the way I've implemented it, it's just like, well, I'll just grab this stuff and it's all going to standard out anyway. So once it gets output, it's not going to matter. And I'm just kind of tracking the file name as I loop over the arguments from the command line. So that's pretty straightforward. I don't think there's anything too interesting about it. The thing that was tricky is like there was just so much like bookkeeping to try and keep track of in your head, and I just like was abstracting out like tiny little subroutines, so I didn't have to like repeat myself constantly because there's so many like little steps you have to be so careful about that if I was copying and pasting that everywhere, it would be bad. I guess I'll show my screen anyway.
Yeah, I would like to see at least like the assembly for a couple of your instructions.
All right. I don't even know if I can look at the full thing, but you know, we'll see like kind of the general idea. So can you see this now?
Yeah.
All right. So these are like the series of like different commands, right? The nag, the EQ, and you can kind of see I have like these little subroutines that kind of just like pop out the boilerplate stuff. So my main approach for a lot of the things was, since R13 through R15 were available for like internal use, that was kind of my scratch calculation stuff. So I would just dump values into there and then do a comparison and then push it back onto the stack basically when that was done. So if we head up to like the definition of pop and store, I mean, like this is super crappy stuff where it's like going out to this thing where I'm like, here's my assembly for assembly for popping something off the stack, and then pop and stores differences. Oh, now that I've got this value here in data, I'm going to go ahead and stick this into whatever address I passed into it. So it's just a way to avoid a lot of like the basic boilerplate. But man, it still feels sort of crummy and inelegant. But as a first pass, I mean, it was effective. I don't know. So I don't feel like I'm doing anything too fancy here at all. Most of this is just concatenating strings of arrays and then dumping those into a file. Or arrays of strings, rather. I had that backwards. So I wanted to mention the one thing that I thought that ended up being tricky, and I couldn't think of a better way to do this, is the comparison functions. because the implementation mentioned what the values for true and false needed to be, and I kind of felt like there should be an easy way to do that, but for some reason I couldn't think of it. And so for every instruction, I'm passing, like for every comparison instruction, I basically set up a little if-then. It's essentially an if-then thing, where if this comparison works out, so you can kind of think of this as like if op here is equals EQ, that's what this is working here. It's going to sub in and say, all right, well, I guess we can do, what's the quote? So this would produce something like equals, and then I is just like a little track of the index line, the index of the line in the file, so I can make a unique one for each command that needs it. So this, for example, might like generate EQ1, and then this would be whenever some data dump if it's equal to 0, and so on and so forth, or yeah, like that. And then here's like the little branches. So this felt like terrible, but I couldn't think of a way where this, like to set those values without doing like this weird little if-then loop for every instruction, which just felt bad. So I'm curious to see what your solution was to this. But yeah, that's pretty much it. So I feel like I got everything working. I didn't actually end up using the virtual machine simulator at all. Like, forget that. I'll use the good old CPU simulator and just run the test scripts and everything will work. And that proved to be easy enough. But on the other hand, I wasn't trying to roll it from scratch either. So that's pretty much what I have. Do you have any questions?
Yeah, can you just show me real quick where you keep track of the file as you're doing the parsing? Because that's the one part that is definitely not in my implementation. I know I know it's something I'll have to address before I can actually get the pointers or the static stuff actually working right. So. Okay.
Yeah, that's actually all handled in like the main function essentially. So command line args is a thing in Clojure that just gives you a list. Well, you know, the command line arguments. So I kind of grab that and do some crappy just ghetto regular expression parsing. So I read in that file, get a reader, and then this here kind of gets the base name of the file from whatever that is, and then that gets passed into when I'm doing the little translation step. I pass that into the translate command, so it's available. And then anywhere, let's see, where does that happen? File. Let's see. There's only two commands that use it, either push or pop. And in that case, well, let's take a look at handle push. Where's file come into play here? Okay, so it'll be like the static segment uses the file thing, and whatever that is, it just uses the ASM compiler itself to generate a new variable, essentially, based on concatenating the file and whatever the index of the segment is. So you end up with a variable like at foo.3. Like if you're doing, I guess I should. So if the command is something like push static 3, then this gives you something like, and your file, let's say it's foo.bm, that would give you something like foo.3, which would be unique wherever you're referencing that value. And I didn't come up with that. That's actually something I got from cheating and reading the implementation section. So yeah, I just kind of took that and thought, well, that's a good enough idea for addressing that stuff, and it'll all be unique. Even across files.
All right. Well, yeah. I think we could probably just jump over to my code real quick.
Great. That'd be awesome. Let me unshare my screen.
All right. So I will say the first thing I actually did in this project, which worked out really well, is I just wrote this. I call it integration test.sh, and it basically just, I can either pass it a specific file, or it'll just go look within Project 7 for all the .tst files, and for each, and it'll basically just turns that into a list, and then for each test file, it just basically configures out like, okay, here's where the VM file lives, here's where I want to translate that to an ASM file, and then it calls my VM translator to do the translation, and then calls the built-in assembler that they provided us on the assembler file that got generated, and then calls the CPU emulator with the test file to check to see if what I generated actually ends up passing all the tests, right?
Right.
And so I end up being able to just call this on my terminal line, like in project 07, I just say /integration test, and it just will try to do all of them. And so I could always check to see what's failing and passing. So like last week, I ended up having a lot of TDD inside my Ruby code. And this week, I started with some and then quickly stopped doing any sort of testing inside my code because the internals of it were changing really quickly, and I really just wanted to know, like I had these really good high-level tests, and so I just was sticking to those and running those a lot. So I'm assuming you were doing something similar when you said that you were just using the good old CPU emulator.
Yeah, but nothing like automated like that. That's way cool.
Yeah, this is like the one. I think this is probably my best idea of the whole week for sure.
Yeah, that's awesome. What would have been great is if I'd thought like stop, because I'm just not familiar enough with Clojure and especially the testing situation around it, and I get such a Clojure mindset. But I really could have used something like that to validate what I was doing, straight up without worrying about the Clojure part of it. So I think that's great. That's awesome.
Yeah. So then really the only other thing that's probably worth looking at is so in my VM translator, this is that thing I was talking about that right now when I'm translating, I currently when I started the project, I just was like, oh, I'll just read in the whole file and I'll just pass the line, like the bytecode, straight to my translator. So my translator right now has no concept of what file maps to which bytecode. So I'm sure I'll have to fix this in order to really make the static stuff work. And I definitely spent some time thinking about trying to break down the individual operations into sort of sub-operations like you did. And I ended up not doing it. And so it turns out kind of weird. So this is basically what I have this VM instruction idea, and I basically pass it a line. The line strips the comment, and if after stripping the comment there's nothing there, I just always make it a no-op, which just emits nothing. But otherwise, I basically take the first two words of the line. So let's see, can I make I'll put this in edit mode for a second so I can kind of type while I talk. Come on, do some scrolling, window. There you go. So anyway, so the idea is if I have something that's like pop local 4, or a better one is push constant, right? Push constant 7. It basically splits. It basically just figures out that these first two words, and then does it kind of capitalizes them and jams them back together to generate something like push constant.
Cool.
And then it just finds the class name push constant within the module, within the VM instruction module, and tries to build one of those classes using the line. And so all I do is just build this list of instructions, and then each instruction has a 2 assemblies, I think is what it was called. So GitHub is not ideal for this, but I'm not on my main computer, so I am just trying to make this work as best we can.
It works. Yeah, let's see one of the instruction classes.
So this push constant is the first one that you really do, right? And all it basically does is it takes in a line, and then I kind of do the same thing. I split on the word boundaries and just say, grab me the last one and turn it into an integer. So now I know kind of my value, and I ended up.
Okay. One thing, just for clarification's sake. So each of the instructions actually gets the whole line again. Is that right?
Yes.
Okay. All right. Cool. Sorry. Go ahead.
So in retrospect, I think I probably didn't need to do that, but that was my initial implementation, and it has worked. So I haven't changed it yet. But anyway, so I have basically this 2 assemblies, and I also ended up adding a commented assemblies to each one of these, so that in my generated assembly code, I could I left little comments to myself oh, I'm about to put all the assembly for my push constant 4.
Dude,
right?
That's so great. I should have done that. That's Oh, that's fantastic.
And then
Man, I needed that. Oh.
and then inside of here, I just like I said, I definitely saw a lot of common cases. So like if you look at push local, and then I guess I can't show you two screens, but if you just sort of remember this pattern right here, and then we jump to push push this, or what's another push? Push temp.
Push argument? Push argument?
Oh, even push temp, yeah, push argument is probably better. And you can see the pattern is almost identical.
Yeah.
And so there's definitely places where I was like, oh, once I get these all working, I can probably like pull out some parent classes. You know, like going back to the instruction class real quick, like there's definitely patterns here, right? Like I kind of have my arithmetic operations. I have all my push operations and all my pop operations. And some of these are vastly different from each other, like the temp ones, because the temp ones are always just like, take this static number, and so like push temp, right?
Yeah.
You always know that it's just going to be a register, and so you just say like, take the value, add 5 to it, and then it's that register number is all you need. And so some of them are very different from each other, but most of them follow a very similar pattern, which is like, oh, I need to calculate the address of the 5th index in the args array sort of thing, and then I need to you know, copy a value into memory, push it onto the stack. So there definitely is room here for like pulling those commonalities out. But once I got each of them working, I just was like, I ran my tests and everything passed, and I was like, good enough, done. I just stopped doing it. And to your point, like the equals operator, I actually ended up following basically the same path, except since each one of these only knows about their own lines, I just, oh, this is so embarrassing. I just generate some secure random data.
That's legit.
So I like give each one of these equal operators like a random address, and since I know that in the assembly step, each one of those just gets translated down to an address anyway, so I know I don't pay a performance penalty for giving them longer names. And so I was just like, it's random enough, they don't collide, so I'll go with it. And then I just have like these little shortcuts for like, oh, jump to the not equal case, otherwise it meant they were equal, and I need to just load this value into the D register, and then I jump over the not equal case, and I always end up in this push result branch where I just basically say like, okay, I know I have the value I want in my D register, so just go push the D register onto the stack.
Yeah, okay, yeah.
So that makes me really curious though, because I was like, so sorry, I'll stop sharing my screen here for a second. But when I got that all working, I was like, oh, I'm sure that since Dan like did this the more professional way, like, he's doing closure. I'm sure he will have found something more elegant than like generating, you know, pseudo-random, you know, labels and doing branch statements, you know, like low-level assembly for branch statements. I'm sure he would have found something better than that. So that's interesting. It makes me really wonder now if there is something better than that neither of us landed on, or not.
Mine was essentially each with index was the only difference.
Yeah, I guess so. And so we would definitely, like, in retrospect, you know, obviously, like, my push static implementation right now, it just assumes that that the static is always starting at value 16. So I just take my value and add 16 to it. And it totally only works as long as you only have one file worth of statics. So eventually my instruction will have to probably receive the line number within the file and the file name or something like that in order to be better about generating these names and these labels for the assembler. But it works, so.
Yeah, it looks great. It kind of reminds me, like a while ago, there's something, I don't know where I saw it, something like, oh, try and implement like forth in Ruby, like a version of forth, which is like a stack-based programming language. And like from what I remember of doing that, it's not GitHub, so I have to look at it again. But like very much as in the same approach where I have like a different file for each command. So it brought that to mind. The interesting thing I thought about, where there's like a lot of repetition in your commands in some cases. Like I got paranoid about that like right off the start. I'm like, man, if I did something wrong with one of these commands, and I need to go back and fix them, and I've just been copying and pasting it, it's gonna suck. I'm gonna have to like try and figure out which commands applied to what. And I was like so paranoid about that I was like, as soon as I had something like the first basic command working, it's like, okay, what commonalities can I extract out of here? Because I was so worried about it. But man, if I just thought of your idea of like throwing in comments, that was genius.
It did. I will say not extracting commonalities. It fit me 2 times during my implementation. There's 2 times where like my first pass at how to do, I think like one of them was all the pops, like the way you pop things into a register. My very first attempt at it, so one downfall of my implementation was that if anytime I got to a VM instruction that I couldn't, or that it hadn't implemented yet, my translator just stops. And so I had to like make a rough draft cut of all the new instructions in a given test before I could even get any feedback about whether I was on the right track. So having kind of these higher level tests as my only safety net, and the fact that I wasn't extracting commonalities bit me exactly twice, which was like the way that I'm pretty sure it's basically like the direction that I branched within my equals and less than and greater than operators, whereas I was wrong. I basically like just took a guess, and I was wrong the first time. And so when I ran the test the first time and they all failed, and I started stepping through the instructions, I could see where I got it wrong, but I had to actually go fix like 5 commands or 5 instructions. And they were pretty much copied and pasted, so it was like I really had to go fix it in 5 places. So that bit me, and I think it was basically my comparison operators and my pops that I made a mistake and had to go fix it in multiple places. And so it definitely did bite me and cost me some time. But in retrospect, the fact that all of my commands were totally self-contained and isolated, and the fact that I had I was pretty surprised that the built-in assembler and the built-in CPU emulator, despite the fact that you need to like spin up a Java runtime, they actually run really fast. So that integration test shell script thing that I wrote, the whole thing runs in about 4 seconds, I think. And yeah, to like do all of my all my translations, all my assemblies, and all of my CPU emulator running the test scripts.
Wow, does it fire up the GUI?
No. So if you invoke the CPU emulator with the test script as its command line argument, it doesn't ever boot the GUI. It just emulates it and tells you the result.
Oh man, that would have got me. That would give me some time back into my life that I've lost forever now. Well, next time.
Yeah. So I think that was somewhat of a lucky discovery that when I had read. I think like during chapter 1, they tell you to read the appendix on the CPU emulator, and I just like sort of in the back of my mind remembered that there was like that you didn't always have to start it in GUI mode. You could just give it a file, and I just tried it and it worked. And so, like it was funny that I think you and I each took different trade-offs, and I'm gonna do this just because ever since I watched the STDD Dead things, I've wanted to do this now in a Google Hangout. So now I'm Kent Beck. But it feels like we both took like these totally different trade-off routes, right? Like you were like, okay, I'm going to be a little bit more proactive about extracting, and I think it was probably because your test feedback was a little bit slower. That made more sense. And I put a little bit more time in initially to automating my feedback, and as a result, I ended up taking a less extracted approach, but it was in some ways easier for me to like look at any one instruction and just be like, okay, let me walk through this again real quick. And there was no abstractions that I had to think through. It just was like, here's all the assembly commands I'm about to generate.
Cool. Well, that's awesome, man.
Well, it seems like we, for once, our implementations still aren't that different, which is pretty funny.
Not fundamentally, I guess. I was hoping that I was doing something stupid with the equals, with the comparison thing. But I guess I actually feel little better now that you came up with the same general idea of using a little branching there. So that's good.
Maybe that is a good implementation, or maybe we are both dumb. We're not sure.
Well, I'll just take it from the great minds think alike point of view.
All right. Bad minds think alike too, I think.
We'll consider that option. Yeah. But you're probably correct.
All right. Well, it sounds like the good news is we have a couple of weeks before we need to. Oh, I guess that wasn't on the Hangouts part, so I'll mention again. Both of us have family vacations going on. We are both Americans who, and as all Americans do, we are lazy and like to take vacations during the summer with our families. And so we will be capitalist pigs and be taking a couple weeks off of the study group to do family vacations and stuff. So the next one will be on July 2nd, and we'll be going over the second half of the virtual machine translator, where you are dealing more with the object-oriented part of the translation steps. And so it should be very interesting to see how our translators from this week, if they hold up under the weight of next week's demands, or I'm sure mine won't. And so it'll be a little bit of implementing new things and a little bit of fixing our existing things. So I think that's it for me. I'm out of comments. This was a very fun week's worth of topic, though.
Yep, I've had a lot of fun. I don't have anything else to add. It's a good time.
All right. Well, thanks again, Dan, and we'll see you in a couple weeks.
All right. Thanks, Mike. See ya.
Have a good night.
You too.
Bye.